Hi guys, Mr. G here coming at you with our second math lesson in our mini division unit. This lesson will be much shorter and we will stick to a much shorter I do. Hopefully that review was helpful for you. You got some of the cobwebs out of there and hopefully maybe you've taken that first little step to taking a look at partial quotient. For today's lesson, you will need piece of paper, again, lined, blanked, graph paper, doesn't matter, and a pencil. The learning targets for this lesson, and in fact for the whole mini unit of division, because it's a mini unit, is I can find quotients with remainders of division problems with single-digit divisors and dividends to the thousands place. I gave an example this time. 1,529 divided by 7. So I hope we're able to do this by the end of our unit. Second learning target, even more importantly, how we do that. I can determine quotients with remainders, just like the last one, last learning target, using standard form or partial quotient strategy. Again, maybe standard form's been working out for you. Maybe it has not. Want to give you one more tool in the toolbox. Let's get after it. Let's have a great lesson. All right, so let's start our I do. Again, during our I do, you are focusing on my instruction. You are not doing anything but watching what I'm doing and learning or relearning the skill. Okay? So if you're not in a place that is going to help you learn and you don't have the materials out in front of you ready to go as we move into our we do, you need to do that right now. As always, you can always pause me. Let's start I do with standard form. We'll be going back between standard form. We'll do a equation in standard form. We'll do the same equation in partial quotient. So we'll be able to see the differences, just like we did in last lesson. So let's review the steps for standard algorithm. Divide, multiply, subtract, bring it on down, and bring it on back. You should be writing those steps every single time on your paper when you're completing a division problem using standard form or standard algorithm. Let's start with this expression or this problem. 348 divided by 7. My first step, I need to divide. The place value I'm dividing with to start using standard algorithm is the hundreds place. So I am asking myself, can 3 be divided by 7? Or I'm thinking to myself, I'm using my strategy. I'm using inverse operations in my head. 7 times a number equals 3. No way. 3 is a much smaller number than 7. Cannot happen. So I need to move over to my second place value. I'm now going to be looking at 34 or 340 actually. So I'm still dividing. Now I need to divide 34 by 7. So in my head, I should be thinking 7 times what number is going to get me 34 or close to it. So I could skip count by 7s, I could get my place value chart out, or I just know my 7s really well. Well, I know my 5s pretty well, and I know 7 times 5 is 35, but that is bigger than 34. So, what's the next factor less than 5? 4. 7 times 4 isn't 34, it's 28. So I stay in my place value, very important. I didn't start my hundreds, I'm now starting in my tens. I divided. Now I need to multiply. I'm going to multiply my divisor by the start of my quotient. 7 times 4, as we mentioned, is 28. Going to erase my thought bubble. I already did that. Next step, I'm going to subtract. I need to subtract 28, from 34. I need to find the difference. I need to regroup. So, can I subtract 8 from 4? No, I cannot. I need to move over to the next place value. Boop, boop. I can subtract 8 from 14. That's going to give me 6. 2 minus 2 is going to give me nothing. Next step, I need to bring it on down. I need to bring on down the next place value. I had to start in my tens, so I'm going to have to bring down my ones. I need to bring down that 8. I brought it on down. Now I need to bring it on back. I need to divide again. What's important is that I understand that I'm dividing 7, not into 3, not into 8, not into 6. I'm dividing it into now 68. I regrouped. I made my whole smaller. My whole now is 68. I still got some number left to divide. I got 68 to divide left in my number, which was originally 348. So in my brain, I'm thinking 7 times what number is going to give me 68? 68 is a big number. So again, I could use a strategy. I could skip count. I could use my place value chart. But I could also think with numbers I know. I know 7 times 10 is what, guys? What's 7 times 10? It's 70 because I am tacking that 0. 70 is too much. That is too big of a number to divide into 68. So I need to figure out what 7 times 9 is. 7 times 9 is 63. That will work. 7 times 9. So I did my inverse operations. I used my strategy. I divided. Now I need to multiply. 7 times 9, we already said, was 63. I then subtract out. I multiplied my partial quotient times my divisor. I got 63. I need to subtract. Can I subtract 3 from 8? Absolutely. That's going to give me 5. I subtract 6 from 6. I get nothing. Next step, I need to bring down. Let's take a look at my next place value. I was in my ones. Oh, I have no place values left. Guys, that means I can't keep going. That means I have a remainder. I have a remainder of 5. Standard form, 348 divided by 7. All right, guys, moving on to I do for a partial product. Looking at that same expression, 348 divided by 7. Quick review with partial product. Obviously, no rules, no steps. You kind of make your own rules, but there is some strategies we want to use. Again, we want to chunk and subtract till we can't, and then add our partial quotients and our remainders. Chunking, okay? New skill, brand new skill. When I'm chunking, I want to use factors I know. Like I said, 2, 5s, 10s. 7 times 2, 7 times 5, 7 times 10. Those are what I want to use. Those are easy. I want to work with easy numbers. Products I find out. You're going to see in a second here that you may be able to think even bigger than 10. You might be able to think 20 with information or knowledge you already knew. And then last, think big first. Get that number chunked down to a small number that you're able to then divide a lot easier using your facts in your math brain. Okay? So, like I just said, 7 times 10, that's the biggest chunk I think I can take out of 348. But here's the thing, that's only going to give me 70. So what if I doubled 10? Let's take a look at this. What if I doubled 10? So we know 7 times 10 is 70. That's easy, right? Tacking 0. So I could find a product, use a product that I find out. So 7 times 0 is going to give me 0. 2 times 7 is going to give me 14. 140. 7 times 20 is going to give me 140. Or I could think in my head, 70 plus 70. Because 7 times 10 is 70. Another 10 would make 20. 70 and 70 would make 140. Let's chunk that out. Let's chunk that out and see what we get. So 7 times 20. I want to put my numbers in the right place values. Oh, forgot. When I set up my partial quotients, I want to put that line down there. So I chunk. I found a factor. I need to multiply. We knew that it was 140. I subtract out. 0 minus 8 is 8. 4 minus 4 is nothing, a 0. 1 minus 3 is 2. 208 is our new whole. We just chunked out 140. 208 is our new whole. So use what you know. Use what you know. I just figured out that 7 times 20 is 140. Guess what? I still can chunk out this 208. Let's chunk that out. Let's chunk out another 20. We know that 140 is less than 208, so it's not going to chunk too much. It's not going to get rid of all of our number. So 7 times 20 again is 140. I subtract out again. 0 minus 8 is 8. I can't subtract 4 minus 0. I got to steal. 4 minus 10 is 6. So I have a new whole. I chunked out 2 big chunks of 20. I got 68 left. So in my brain, I'm thinking 68 divided by 7. Or I'm thinking 7 times a number equals 68 or close to it. Let me think about 10 first. I know 7 times 10 is 70. That's easy. 70 is too big though. 70 is 2 more than 68. I can't chunk out a 10, but I can chunk out a 9. So 9s are tough. 9s are really tough. I could use a number of strategies. Okay, I could split. I could use my place value chart. I could use the 9s trick. Check this out. Ready? 7 times 9 going left to right. 1, 2, 3, 4, 5, 6, 7. I have, look, 6 10s, 3 1s. What's that make? 63. 63. That works. Let's chunk that out. So I figured out 7 times 9 is 63. What do I do next? I subtract out until I can't. 3 minus 8 is 5. 6 minus 6 is nothing. So I chunk until I can't. I chunk and subtract till I can't. Can I divide 7 into 5, guys? I cannot. I cannot do that. We found our remainder. Let's put our remainder here. Remainder 5. Okay. What do I need to do last? I need to add partial quotients and my remainder. So over here, I'm going to do that. I'm going to add my bigger numbers first. I'm going to reorganize, guys. Don't try to add in this little space here. It's going to mess everything up. 20, 29. I go backwards, whatever. That's going to give me 0 plus 0 is 9. 2 plus 2 is 4. 49 with a remainder of 5. All right, second step to our lesson structure. we do. So again, for the we do, you now have the paper and pencil in front of you. You are working as I'm working, as if we were working together in the classroom. Again, kind of weird. You can always pause me to stop if I'm going too fast. I'm going to try and pause to allow you to work with me. But if you miss a step, pause the video, go back to where you left off, and learn with me. That's what the we do's all about. Let's stay with partial products so I don't have to rearrange my board here. Let's go. Let's go to the thousands. Let's go to the thousands. 5,483 divided by 4. So again, chunking. Factors I know, products I find out, thinking big first. So if I wanted to think big first, I wanted to think real big. I got a huge place value here. I know that I can start, much like in standard algorithm if I want, I could start anywhere. So I could start in the hundreds, the tens, the ones. In this case, I probably couldn't start in the ones because 3 is smaller than 4. Why don't we go ahead and look at the numbers? I see that there's a 4 here and a 4 there. I know 4 that can go into 4, right? 4 times what number is going to give me 4? 1. Okay? 1. But here's the thing. What place value are we in? We're in the hundreds. Tack those 2 zeros. So I'm thinking 4 times what number is going to give me 400? I know 4 times 1 is going to give me 4. I tack 2 zeros. 100. 4 times 100. Go with me. 400. I chunked. I thought big. Now I'm going to subtract. Oh, I forgot again, guys. There it is. Okay. We're all here. We just chunked. 4 times 100 is 400. I'm going to subtract it out. I'm going to regroup. I will find a new hole here. 0 minus 3 is what? 0 minus anything is going to give me what, guys? It's going to give me that number. 3. 0 minus 8 is going to give me what, guys? It's going to give me 8. 4 minus 4 is going to give me 0. Don't forget this 5. Working with the thousands, nothing minus 5 is going to give me 5. Our new hole, 5,083. I chunked out 400 there. 400 is a pretty big number. All right. We need to chunk and subtract till we can't anymore. We still got a pretty big number here. Looking at the numbers. I see an 8 here. But I also know that a 4 can go into a 5. Not equally, but I know that I can figure out using my strategies, thinking big. Let me think, if I'm in the thousands place, if I multiply 4 times 1,000, what am I going to get? If I want to get to a number close to 5,000, okay, I know I could divide 4 into 5,000. I know I could divide 4 into 5. What's 4 times 1,000 going to give us, guys? All I'm doing is tacking 3 zeros, 4,000. Can I put 4,000 into 5,000? Absolutely. Let's do that. 1,000 is our new factor. So we use the strategy. We found out a product that I find out. We just figured out a product using our mental strategies. 4 times 1,000 is going to give me 4,000s. Let's chunk this thing out. Big number. 4 times 1,000 is going to give me 4,000. I subtract it out. Subtract with me. 0 minus 3 is going to give me 3. 0 minus 8 is going to give me 8. 0 minus 0 is going to give me 0. 4 minus 5, 4,000 minus 5,000 is going to give me what? It's going to give me 1. 1,083 is our new number right there. So I still want to think big. I still want to chunk big numbers out of there. Why don't we continue looking at these numbers? See if there's any friendly ones here. Looks like an 8. I know that 4 can go into 8. How could I do that? So 4 times a number equals 8. But I know I'm not working in with ones, I'm working in the tens place. So or I need to think of a number. 4 times what's going to give me close to 80? Well, I know 4 times 2 is going to give me 8. If 4 times 2 is going to give me 8, and I need to get to 80, which is just tacking a 0, how about we would go 4 times 20? What's 4 times 20 going to give us, guys? If 4 times 10 is 40, and we doubled that 10 to make what? 80. 4 times 20. Let's take a look at it standard form. 4 times 0 is 0. 2 times 4 is 4. Oh, yikes. 8. Just made a mistake. Brain fart. 4 times 2 is 8. 80. Let's do it. We just found another product. We're thinking big. 4 times 20 is going to give me 80. I subtract out again. 0 minus 3 is 3. 8 minus 8 is nothing. Nothing minus 0 is nothing. Nothing minus 1 is 1. 1,003 is our new whole. So, I know that 4 can't go into 3. That's not friendly. But I'm still working with a pretty big number here, so I can still think big numbers. I know 4 can't go into 1. It can't go into the thousands place. So let's think about making a number that's in the hundreds. How do we make numbers that are in the hundreds? I need to tack how many place values? Here's 100. I need to tack 2 place values on there, especially if I'm working with one number. So let's try 4 times 100. Guys, what's 4 times 100 going to give me? Let's find out standard algorithm. 4 times 0 is 0. 4 times 0 is 0. 4 times 1 is 4. 4 times 100 is going to give me 400. 400, excuse me. That's because I know 4 times 1 is 4. And if I were to tack 2 zeros to my 4, be 400. Let's chunk that out. Let's put my 100 right here. I chunk it out. 4 times 100, we just found out, is 400. I subtract. 0 minus 3 is 3. 0 minus 0 is nothing. 4 minus 0 is what, guys? Can we do that? Can I subtract 4 from nothing? I have nothing here. I cannot. I need to steal. I need to steal that 1. 4 minus 10. What is 4 minus 10 going to give me? It's going to give me 6. Okay, we're working on a big problem here. I have 603 now as my new whole. That's the number I'm looking to divide now. So, I have all my partial products up here. So, I now need to look at these numbers again and see if there's any friendly numbers. I know I'm still working with 100. I'm 603. I'm still in the hundreds place. I'm thinking that we do that again. I think if we multiply and we get 400 again, why don't we do that? Use what I know. 4 times 100 is going to give me 400. Again, guys, you need to give yourself lots of space. I'm obviously very limited on the whiteboard. I have to make it big enough for you guys to see. So I subtract out 603 minus 400. Okay. 0 minus 3 is 3. 0 minus 0 is 0. 4 minus 6 is 2. 203 is my new partial, is my new whole. So, I need to now again look at friendly numbers. Need to look again at friendly numbers. Taking a look, I know that 4 can't go into 3 evenly, and it can't go in at all, and 4 cannot go into 2 at all. But, looking at 20, can 4 go into 20? This is obviously 200, but I know if 4 can go into 20, how many times can 4 go into 20, guys? 4 times what number is going to give me 20? 5. 4 times 5 is going to give me 20. So, if I'm putting my 5 in the tens place, that's going to give me 50. So I wonder what 4 times 50 is going to give me. Let's take a look. Let's see what 4 times 50 is going to give me. 4 times 0 is 0. 4 times 5 is 20. 200. Can we chunk 200 out of 203? Absolutely. We absolutely can. That's a pretty big chunk. Let's chunk that out. Let's chunk that out. 4 times 50 is going to give me 200. So guys, we had to move over here, okay? And on your paper, you'd be down here, okay? You'd be working down your paper. Give yourself plenty of room. 203 minus 200, going to get a new whole here. 0 minus 3, 3. 0 minus 0, 0. 2 minus 2, 0. Look at that, guys. We got all the way down to our ones place, a 3. Can 4 go into 3? We need to chunk and subtract till we can. Can 4 go into 3? 4 times a number equal 3. Nope. Right? Can't do it. So what does that mean? That means we have a remainder of 3. Let's write our remainder right here so we don't forget. Next rule. Not a step. Next rule. We just made our own rules here. Look how many different steps we made, all with our own brains. Add the partial quotients and the remainder. We need to add all these numbers. Let's do it. When we're adding our numbers, listen very carefully. When we're adding a lot of numbers, we want to start with our biggest number first. We want to start with our bigger number first. 1,000, we got 3 hundreds. We have a 50 and a 20. So, before we add, let's make sure we're on the same track here. I have 1,000 partial product I'm adding. I have 100, another 100, another 100, a 50, and a 20. These are all the chunks we got to add here. That's a real chunky partial product problem. Pretty soon this problem's going to look like Mr. G with all the food he's been eating. I'm going to keep making that joke, just so you guys know. I got zeros. If I add a whole bunch of zeros, what am I going to get, guys? I'm going to get 0. 0, 0, 0, 0, 5 and 2. What is 5 and 2 going to give me if I add them? 7. I now have to add 0, 1, 1, and 1. What is 1 plus 1 plus 1 going to give me? 3. And 1 plus nothing is going to give me 1. Guys, we have our quotient. We have our quotient. partial quotient strategy. Was I calling it partial product strategy again? I think I keep doing that. So 1,370 is our answer, but don't forget to add your remainder. Remainder 3. Whew! That was a good redo. All right. Another redo. That last redo was pretty long, so this is going to be our last redo. We're going to do standard form. Hang in there, guys. We want to learn both skills, okay, to make sure we have all the tools in the toolbox that we need to be successful. Let's review the steps first for standard algorithm. You need to always write them on your paper when you're using this strategy to help you. Say them with me. Sing the song if you really want to. Divide, subtract, multiply. Oh my gosh, I just made a mistake. Divide, multiply, subtract. Bring it on down and bring it on back. Here's our problem. Let's go 6 as our divisor. And let's go, we want to stay with thousands. Let's go 6,473. 6,473 divided by 6. Get that on your paper. Let's get started. When we are dividing with standard form, we start in what place value? The hundreds. Can 6 go into 6? In my thought bubble, am I thinking 6? I am thinking 6 times a number equals 6. Can 6 go into 6? Absolutely can. 6 times 1 equals 6. But I'm in the thousands place. 6 can go into 6,000 1,000 times equally. What's my next step? I divided. I multiply. Need to multiply my 1 times my 6, my partial quotient, the start of my quotient, times my divisor. 6 times 1 is 6. We knew that. We subtract. What's 6 minus 6 going to give us? Nothing. We subtracted. Next step, we need to bring it on down. I'm going to bring down my next place value. My next place value is in the hundreds. That is our 4. I bring it on down. Bring it on down. I bring it on back. I divide. I need to divide now, not 6 into 473 or 6 into my 4 here. I'm dividing 6 into my new whole that we started right here. Is our 4 in the hundreds place? 400. Can 6 be divided into 4? So in my head, I'm thinking 6 times a number equals 4. Can't happen. Guys, what do we do when we need to bring down? We've already brought down, and we still need to divide. What do we need to do? We can't divide 6 into 4. It can't happen. What do we need to do then? We need to bring down another place value. We need to regroup again. 47 is now our new whole that we want to work with. Actually 470 because we're in that place value. Okay, we're in the hundreds, in the tens. Can I divide? Still dividing. Okay. I needed to bring back down again because we couldn't divide into 4. I still need to divide. Can 6 go into 47? It absolutely can. So in my head, I'm thinking 6 times a number equals 47. I use a strategy. I skip count. I split. I use my multiplication chart. I'm going to use some estimating. I know that 6 times 5 is 30. So I'm going to add 6 a couple times. 6 times 6 is 36. 6 times 7 is 42. 6 times 8 is 48. Oh, 48 is way too big. So 6 times 7 will give me 42. Let's do that. But here's the thing, guys. I'm now working in this place value. Very important. Now that I am not working with my hundreds, I need to put a 0 there. We moved all the way here to our tens place. So we need to put a 0 here. Okay, important step. We brought down again, so we needed to put a 0. 6 divided by, 6. There's our 7. It's in the right place value. 6 times 7 is, what did we talk about? 42. This is a 7. I subtract out, I multiplied. So I divide, I found 6 times 7, figured it out, can go in. I multiplied, I got 42. Now I need to subtract. So we need to subtract 42 from 47. 2 minus 7 is going to give me what, guys? 5. 4 minus 4 is going to give me what? Nothing. I subtract. What's my next step? I need to bring it on down. I need to bring down my ones all the way down here. Great. And I need to bring it on back. I need to divide. Now, I need to divide 6 into 53. We made a new whole when we regrouped here. So I'm now asking myself what 53 divided by 6 is. Or can 6 go into 53? It absolutely can, but I want to use my inverse operation strategy. 6 times what number is going to give me 53 or something close to it? Well, as mentioned before, I know 6 times 5 is going to give me 30. Let's take a look on a number line here. This is 5. Okay, and this is 10. I know 6 times 10 is going to give me 60. And I know 6 times 5 is 30. Which is closer, 60? Which is closer to 53? 30 or 60? Absolutely. 60 is closer to 53. In fact, it's too big. So we need to multiply 6 times 9. Let's see what that gives us. Number of strategies, use your multiplication chart. I want to do 9's trick again. So 6 times 9. 1, 2, 3, 4, 5, 6. Put it down. 5 tens. 50. 4 ones. 54. Oh, is 54 going to work? 54 can't work. It's too big. It's 1, 1 too big. So what's that mean, guys? I need to go to 8. I'll give you a break. 6 times 8 is 48. We can use 48. 8. 6 can go into 43. 6 can go into 53. Not equally, but it can go in 8 times. We divided. We did all that mental math to divide. What's our next step after we divide? We need to multiply. 6 times 8, we already said is 48. I am now subtracting 48 into 53. Can I subtract 8 from 3? If I have 3, can I subtract 8? If I have 3, can I subtract 8? 1, 2, 3. No, I cannot. I need to steal. This 5 tens becomes 4 tens. I bring that 10 on over. Can I subtract 8 minus 13? Absolutely. Or excuse me, yes. Can I subtract 8 from 13? I can. I'm going to get 5. 4 minus 4 is nothing. I subtracted. I need to bring it on down. Oh, let me go to my next place value. Guys, there's nothing there to bring down. What does it mean when I have nothing to bring down? I need to see if I can divide. 6, can it go into 5? Absolutely not. 5 is smaller than 6. What does that mean? I have a remainder of 5. 6,473 divided by 6 is 1,078 with a remainder of 5. Another tough we do. Last step to the lesson, the I do. This is when you get your piece of paper, your pencil, a fresh one. You write an I do on it. This is where you work your skills independently or maybe some help from mom and dad. Here they are. So, using standard form or partial quotient, I think I was saying partial product again a few times, not okay. Partial quotient, solve these 5 problems for your I do. 753 divided by 5. 782 divided by 7. 964 divided by 6. 982 divided by 3. 9,814 divided by 9. Give them a shot on your own. If you need help, reach out on Google Classroom. Reach out on the Flipgrid that's on this video. We will work with you to help you. Yearn to learn, guys. We're doing great. Keep it up.